Hi everybody. So I just want to do another quick video to show you how to use Interact for Lab 3. So I have Interact pulled up, and then the first thing I'm going to do is go and change the dictionary into the USA Combined Surveyor. And then I want to import our occupational identities. So I scroll down to import export. And then I'm actually going to go over to the course website, find February 10th, the aux text file, click on it, do the Control A, Control Copy, and then share again, go back to Interact, copy it, paste it, and then import entries. Excellent. Okay, so now let's say, for example, I'm interested in a dyad between an architect as my actor and my object is going to be engineer. I think I'll do civil engineer. Let's see, civil engineer. Okay. So now if we're interested in the characteristic emotion of each, we go to the feeling effects page, find it on here, architect and engineer. Civil engineer. Okay, and then you say characteristic emotion. We go over here, 207, 226, 0.59. So that is the actual 3-digit profile of the EPA, and you copy it. And if we want to find the closest term, there's this really nice page called Find Concepts. And if you go over here, the first thing you should do is change, because we're looking for emotions, we want to change to modifiers, and then take away traits status feature, and then go Control A, copy, paste, enter. Okay, so architects are most likely to feel self-satisfied, proud, optimistic, or amused when their identities are perfectly confirmed in an interaction. Just as a note, so you'll see there's a comma here and there's a comma here. So the middle are the 3-digit profile of that emotion. So self-satisfied is 2.37, 2.39, 0.48. And this is the distance it is away from our exact characteristic emotion EPA. And so you'll see the smallest is the first one. So if you ever get asked what's the closest, just pick the very top one. Okay, so now if we go back to feeling effects, we can see, okay, what is the characteristic emotion like for an engineer? So if we go to find concepts, we can do the same exact thing, press enter. Okay, so pretty similar, but proud is showing up first and then self-satisfied. So the big difference here seems to be in the activity. So engineers are seen as, more active, and so their emotions are also more active. So that's the characteristic emotion part. The second part has to do with finding the optimal behavior between all of our dyads. So what I'm going to do is just between architect and civil engineer is you just hit compute solution and it will enter into here. So 0.17 away is turn to, 0.24 is consult or ask or agree with or concur with. So these are behaviors that suggest mostly good, a little bit powerful, but not very active. So things kind of like being an acquaintance with someone, or someone you have to work with, which makes sense considering architects and civil engineers are very similar in their occupations. So what we can do then is copy that. And so for the very last part, I ask you to actually go through and simulate these events. So to do that, that's what we're doing now, is we'll press copy and then go to define events, just paste it in here, press enter, press insert, and then go to analyze events and hit the event. So the deflection is 1.1. So then we can write down the predicted emotion, this is where you find the EPA profile, is always in these little boxes at the bottom. And then the list above are the closest terms. And this again is the distance away. So the smallest is the first one. So we think after an architect does something like turning to a civil engineer, they'll feel amused or charmed. They'll continue doing very similar behaviors. They'll maybe dine with or ask the civil engineer something. How might we give them an attribute? Okay, so that might be like cute, flexible. How would we label them? So this is sort of like what is the identity that would be very similar to do this behavior to this object. And so we can also look at the object side. So after an architect does something like turning to a civil engineer, the object feels awestruck. We think they're likely to respond by replying to the architect. No words in range just means there's nothing close enough. And if this happens, like, you can just not report anything here because it's a little bit harder to change that distance measure on the like actual simulation page. So that's okay, you can just not report one, but you should report these. And then we can relabel them by saying, okay, well, what is an architect? What sort of occupational identity do we think an architect would be turning to? Okay, so if we go back to our feeling effects page, we can also find the opposite interaction. So what happens when we ask a civil engineer and an architect? Okay, so again, we hit compute. Okay, so we think a civil engineer is likely to answer or caution or chat with an architect. So the thing I think is most interesting here is that answer or caution are a bit different in terms of I think the power, lower in power, which is kind of interesting. So then if we want to simulate this event, see what the outcome is, we go to back to our define events page. And just like a pro tip here that I think is kind of nice is you can just like change this here. If I want to say civil engineer, architect, and then we put in our identity, or I mean our optimal behavior. Okay, let me go to analyze events. Okay. Dang, I really messed this up. Okay. Let's go back to the feeling effects page and copy that again. So we copy the behavior, we go back to our define events, and we just do it by hand because that doesn't mess up. We insert. But big thing is definitely make sure you change which one's the actor and which one's the object. Okay, now we go to analyze events, hit that, and there we go. So now you can see sort of similar outcomes. And so you'll do that for all of the different dyads of judge and lawyer, lawyer, judge, judge, paralegal, paralegal, judge, lawyer, paralegal, paralegal, lawyer. Yeah,